Synthetic data for language models, a deep dive. The impressive capabilities of AI models, particularly large language models (LLMs), heavily depend on the availability of massive, diverse, and high-quality datasets. However, acquiring such datasets is often expensive, time-consuming, and may raise privacy concerns. Synthetic data has emerged as a powerful alternative to address these challenges. This technique involves generating artificial data that reflects the characteristics and patterns of real-world data, providing a flexible and scalable solution for training and evaluating AI models. The power of synthetic data in training. Synthetic data has demonstrated remarkable success in various AI domains, including reasoning, math. Synthetic data plays a crucial role in training LLMs for mathematical reasoning tasks. Techniques such as generating synthetic questions and answers, rephrasing existing problems, and combining synthetic data with verification processes have significantly improved LLM performance on complex mathematical problems. For example, AlphaGeometry, trained on 100 million synthetic data points, exhibits problem-solving skills comparable to a human Olympiad gold medalist. Code. Synthetic data allows training LLMs to understand and generate code. Simulated environments provide feedback on code execution, enabling models to learn code optimization and improve reasoning abilities. Other reasoning tasks. Synthetic data also boosts performance in other reasoning areas. For example, replacing natural language labels with symbols and generating synthetic chain of thought rationales have led to improvements in in-context learning and algorithmic reasoning tasks. Tool using and planning. Tool using. Simulated tool using trajectories enable LLMs to learn to utilize external tools like calculators, search engines, and translators. Lambda, Toolformer, and Toolopaka are examples of models trained on synthetic data to develop tool-using skills, enhancing their reasoning capabilities and adaptability to various tasks. Planning. Synthetic environments provide feedback for training LLMs to plan and decompose complex tasks into subtasks. Inner Monologue and Voyager demonstrate how LLMs trained in synthetic environments with natural language feedback learn to plan effectively and achieve goals in both simulated and real-world settings. Multimodality. Vision to text. Synthetic data allows grounding visual input to LLMs. By rendering HTML code, tabular data, or even physical simulations, models learn to accurately describe visual information, extract information from charts, and convert web page screenshots into code. Multimodality instruction following. Generating synthetic question-answer pairs with images and text enables LLMs to follow instructions in multimodal scenarios, contributing to a more comprehensive understanding of information. Multilingual. Back translation augmentation. This technique creates synthetic parallel data from monolingual sources, improving multilingual translation capabilities in LLMs. Multilingual queue and a generation. Generating synthetic question-answer pairs in multiple languages has shown to improve LLM performance on multilingual question answering and information retrieval tasks. Alignment. Instruction following. Synthetic data allows for large-scale training of instruction-following models. Techniques like self-instruct, Stanford Alpaca, and UltraCat generate diverse and complex instructions, allowing LLMs to learn to follow instructions and complete tasks effectively. Mitigating hallucination. Synthetic data containing factual inconsistencies or open-ended questions helps train LLMs to recognize and avoid generating inaccurate or misleading information. Human values and preferences. Synthetic data provides a scalable and cost-effective approach to train reward models that reflect human values and preferences. Techniques like constitutional AI and RLHF with synthetic data help align LLMs with ethical considerations and societal expectations. However, ensuring high-fidelity synthetic data that captures the nuances of human judgment remains crucial. Synthetic data in evaluation, assessing capabilities and risks. Synthetic data plays a vital role in evaluating various aspects of LLM performance. Factuality. Synthetic data helps assess the factual consistency and accuracy of LLM outputs, identifying and mitigating potential hallucinations. Safety. Red teaming techniques utilize synthetic data to evaluate the safety and robustness of LLMs, exposing vulnerabilities and potential biases. Assisting human evaluation. Synthetic data can serve as a reliable and efficient alternative to human evaluation in certain tasks. Benchmarks like Alpaca Eval and MT Bench leverage synthetic data and LLM-based judgment to assess the capabilities of chatbots and other language models. Challenges and limitations. Navigating potential pitfalls. Despite its advantages, synthetic data also presents some challenges. Misinformation. The ability of LLMs to generate realistic synthetic data raises concerns about potential misuse for creating and spreading misinformation. Establishing ethical guidelines and developing detection mechanisms are crucial for mitigating this risk. Ambiguity in AI alignment. Synthetic data may not fully capture the complexities of human values and preferences, potentially leading to ambiguity in AI alignment and unexpected model behaviors. Carefully considering the limitations of synthetic data and employing robust validation techniques are essential. Evaluation decontamination. Training with synthetic data can complicate evaluation processes by introducing rephrased versions of benchmark data, making it harder to detect contamination and ensure fair assessment of LLM performance. Future directions. Advancing synthetic data for responsible AI. Several promising avenues exist for future research. Scaling synthetic data. Investigating the scaling laws of synthetic data is crucial for understanding the optimal balance between quantity and quality in LLM training. Improving quality and diversity. Developing techniques to control and manipulate attributes of synthetic data will enable the creation of diverse and customizable datasets, mimicking real-world data more accurately. High-fidelity scalable oversight. Exploring the use of synthetic data for comprehensive and efficient oversight of complex AI systems is essential for ensuring responsible development and deployment. Emergent self-improvement. Investigating the potential of models to generate higher quality synthetic data than their training data. Enabling self-improvement and autonomous learning is an exciting area for future research.